systems of linear equations in three variables. So again, the idea from the previous section is here, but just a little bit more advanced, just because we have more things going on. We have not just two equations, but we have three equations. And not just two variables, we have three to solve. So I'm going to introduce this system, the solution of this system of linear equations in three variables by, I think, is a method that is universal, and it helps you to be consistent so that you get the right information. So what I mean by that is, if you read the book, read the section in terms of how the author explains it, to me he's kind of all over the place, and you get trapped. I know I was trying to follow his method to solve it, and even my answers were not consistent. So I said, let me just go ahead and give you the method that I know, that I've been solving and using for over 30 years. And it's more concise. So according to your book, this is what your author gives you in terms of solving these variables by eliminating the variables. Reduce the system to two equations and two variables. So basically you have three equations, three variables. He wants you to try to reduce back to something that looks like the previous section. I mean, that's ideal, that's great, but how do you get to that and how do you do that is very questionable. Now here's my method. We want to be able to reduce a system into what's called echelon form. I give the definition for echelon, which is basically just a stair-step pattern. Now, this example that I give here, 3x minus y plus 3z equal to 12, and the 4y plus z equal to 10, negative 2z equal to 4, that's what's called already in the echelon form. Now what that means is, if I can reduce a system that has three variables, that is three unknowns, and three equations to something that looks like this, then I can solve. If I can reduce to this form, that's our goal. What does that mean? I want to be able to reduce the three equations, three unknowns, down to where I have one equation with one unknown, I have another equation with two unknowns, and then I have the third equation with three unknowns. Because the idea is, if I get it like this, then I can look at that bottom equation, I can solve for z. So I can take here negative 2z equal to 4. Well, I get z equal to negative 2. And then I take this value for z here and plug that back into this second equation. So basically, I'm going to walk up the stairs. Okay? So I take that value for z, plug it here, then I can solve for y. So there I get y equal to 3. Once I have that, now I have the value for y and the value for z. Now I can solve for x. And that's what I do over there. Now, it's almost like giving a sermon where, I mean, that sounds easy enough, but putting it into practice is the challenge. So let me give you the steps that I use to doing this. Again, we call this row echelon form. To reduce to echelon form, we must utilize the rules for Gaussian elimination, that is the elimination method applied to systems with more than two equations. Well, here are our only three operations that we're allowed to do, and that is, I can interchange equations. I can take the first equation and I can write it as the second equation and put the second equation as the first equation. It doesn't matter how you order those equations. You can multiply an equation by any number you want except 0. So we saw that in the so-called addition method, right? For that previous section, we took that one equation, I think we multiplied it by like a negative 4 or something like that. That's what that step, number 2 operation says. And then you can multiply one equation. You can add a multiple of one equation to another equation. Again, that's the same as the addition method. I wanted to give you this just to show you the positions And these subscripts just denote like equation 1, equation 2, equation 3, or we call them rows. So this is like row 1, row 2, row 3, and then this is column 1, column 2, column 3. So the subscript just denotes the row column. So this is the first row, first column. This is first row, second column, first row, third column. So use the elementary row operations. The goal, remember, I want to try to get this in this so-called stair-step pattern. So I want to have something like that where, if possible, cancel this guy, cancel this guy, cancel that guy. So I tell you here, use A11, that is, use this position to cancel out this term and use that guy to cancel out that. Now, how do we cancel? We're using the so-called addition method. So that's this first step. And then the second step is to use A22 to cancel out A32 right below it. And then that gets us back into something that looks like this form here. Now, with that said, it doesn't have to be that neat. Basically, here's what you want. You just want to end up with one of those equations with one variable in it, one equation with two variables in it, one equation with three variables. Which ones? That's your choice, okay? For me, I think it's just kind of ideal to kind of walk through these steps just to kind of be consistent. So after that, the system is set to be in row echelon form. Then you can solve for z and then back substitute z into the second equation, solve for y. Finally, back substitute y and z into the first equation to solve for x. Basically, I'm just rehashing what we did here. See, we got z, back substitute to get y, and then use y and z to get x. And so that's what I'm saying in this statement here. Again, sometimes it does not matter on the order of reduction as long as you have, again, one equation with three terms, three variables, one equation with two variables, and then one equation with one variable. Okay. Well, let's see how that works out. So here, we want to solve the system, the given system of equations. So what I'm going to do is I want to take this guy to cancel that x and cancel that x. So to do that, I'm going to say negative times equation 2, bless you, and negative times equation 3. So here I have x plus y plus 3z is equal to negative 11. And then I'm going to negate, this is negative x minus y minus 7z is equal to 27. And then this is negative x plus 4y minus 7z is equal to 52. Okay. So now I'm going to add that first equation to the second equation. That's going to cancel out that negative x right here. I want to cancel this guy out. I want to cancel that guy out. So what am I doing? Let me go back. I'm following this. I'm using A11 to cancel out what's below it. So I'm doing that step there. Okay. That's what I'm doing. So when I do that, I'm going to put the new form over here. So that first equation stays the same. X plus y plus 3z is equal to negative 11. Now I'm going to add row, add row 1 to row 2, or that is add equation 1 to equation 2. So equation 1 plus equation 2 gives us a new equation 2. Okay. So when I add x minus x, that goes out. Here, x minus y, well, that goes out. Thank you for that. 3z minus 7z is minus 4z. That's equal to negative 11 plus 27. That's a 1 and a 6. Okay. Well, they just kind of helped us by automatically that y went out too. So praise his holy name for that. So maybe after this last step we can solve, because think about it, right there I can solve z is equal to negative 4. See that? Yep. So now I'm going to add here, we're going to say equation 1 plus equation 3. So x minus x, that goes out. Y plus 4y is 5y. 3z minus 7z is minus 4z, and that's equal to negative 11 plus 52 is, what is that, 41? All right, so now I can take, all right, I can take it to the apartment. Look, notice that since we have negative 4, this is what I want. I have one equation with 3 unknowns. I have one equation with 1 unknown. I have one equation with 2 unknowns. 1, 2, and 3, right? Good. So now I get negative 4z is equal to negative 16. So, I'm sorry, positive 16. Thank you, Michael. So z is equal to, he's a smart guy. Years ago, I had a guy in class. His name was, I think, Alex or Alex. So I would say he's a smart Alex, right? So, but he's a smart Michael. So, so this is z equal to negative 4. Good. Booyah! So now I take z equal to negative 4, plug that into that last equation to get y. So this is 5y minus 4 times negative 4 is equal to 41. 5y plus 16 is equal to 41. 5y is equal to that 41 minus 16. 5y is equal to, what is that, 25? And then I get y is equal to 5. So I get z equal to negative 4. I have y is equal to 5. Take the first equation, I can get x. This is x plus y plus 3z is equal to negative 11. I'm solving for x plus y, that's 5, plus 3 times z, that's negative 4, is equal to negative 11. So I have x plus 5 minus 12 is equal to negative 11. So this is x minus 7 equal to negative 11. So x is equal to negative 11 plus 7. So we get x is equal to negative 4. Okay. So my solution set is x equal to negative 4, y equal to 5, and z equal to negative 4. So we have these 3 planes, and they intersect at this point here, negative 4, 5, and negative 4. We draw it out in the 3 space. It's a line. So the cool thing is that you have lines in the 2 space. They intersect at a point, but then planes in the 3 space intersect at, it looks like a point, but if you look at it from the side, it's a line. Right? It's a girl. It's a girl. Okay. Okay. So do that. So negative 4, 5, negative 4. All right. So let's look at this one. So we're going to solve. I'm going to write this way. X plus 3y minus z is equal to 11. 6x minus y plus 3z is equal to 10. 3x plus 3y minus 4z is equal to 23. What I did was I interchanged equations 1 and equation 2. Okay. Why did I do that? Let me go back and show you. The 3 elementary row operations, I can interchange equations. Okay. I can put those equations anywhere I want to. I like to always start, if possible, that first equation, that first variable, I just kind of want it by itself. You know, I don't want a number associated with it. So that guy was already worked out for us in that second equation. So I just pull that guy upstairs. It's just an x by itself. Yep, he's all alone in the world. All right, so now what I'm going to do is, what my goal is, I want to be able to try to cancel out a variable. I want to cancel out the 6x and cancel out the 3x. I'm going to do it in steps. First, what I'm going to do is I'm going to multiply that first equation by a -6. So -6 times equation 1. Okay, so that gives me -6x. Oh, sorry. So that's -6 times that 3, -18y, and then this is plus 6z, and that's equal to -66. I'm going to rewrite that second equation. Okay. I'm just going to go ahead and put this third equation there, just kind of keep everything together. He doesn't like to be alone. Poor soul. He's just too high strung. So now I'm going to add equation 1 to equation 2. Plus equation 2. That gives me a new equation 2. So here, equation 1, that -6x minus 18y plus 6z is equal to -66. So I'm adding 6x. This is minus 19y. This is plus 9z, and that's equal to -56. So here, I'm just going to rewrite this guy. This is 3x plus 3y minus 4z is equal to 23. Now what I'm going to do is go back and just write the original equation 1. So that's x plus 3y minus z is equal to 11. Here I have -19y plus 9z is equal to -56. And then this is 3x plus 3y minus 4z is equal to 23. So now I'm going to multiply equation 1 by -3, because my goal is to be able to cancel this guy out. So -3 times equation 1. This is -3x minus 9y. That's plus 3z is equal to -33. Just rewrite everything else. This is 3x plus 3y minus 4z is equal to 23. Now I'm going to add equation 1 to equation 3. So this is negative 3x, just rewriting that first equation, minus 9y plus 3z is equal to negative 23. Negative 19y plus 9z is equal to negative 56. So now I'm adding, so this is negative 3x plus 3x. So we add this position to that, adding this to that, this guy there, and then adding. So I'm going down like that. So the 3x cancels out. Negative 9y plus 3y is negative 6y. And this is minus z. And then that's equal to, what is that, negative 10? Negative 33 plus 23, negative 10. Okay. All right. So now I'm going to put the original equation 1 back. I only did the multiplication just to be able to cancel. So that's x plus 3y minus z is equal to 11. This is negative 19y plus 9z is equal to negative 56. Negative 6y minus z is equal to negative 10. All right. So I have 3 equations. One equation has 3 unknowns, x, y, z, and 2 equations have 2 unknowns. So of the 2 equations, I need to be able to cancel out one of those variables. So I'm looking at the y, I'm looking at the z. Looks like the easiest thing to do is to multiply to that third equation by a 9 to be able to cancel out the z's. Because if you look here, negative 19 and negative 6, well, they don't have anything in common. But this 9 and this 9z and the minus z, if I multiply everything here by 9, that'll give me at least a negative 9z there. And then I add those two, add everything correspondingly, then the z's cancel. So I'm going to multiply that third equation by a 9. So x plus 3y minus z is equal to 11, and negative 19, 9, and 56, negative 19, 9z, and 56, that's plus 9. And then we're saying 9 times equation 3. All right. So 9 times everything here. So that's 9 times the negative 6. This is minus 9z, and that's equal to, what was that over there? Is that a 10? So that's negative 60. And it's a negative 56. All right. So now we add row 2 to row 3. So equation 2 plus equation 3, it gives us a new equation 3. So here's the first equation. second equation. The third equation. All right. So we add this second equation to the third equation. So this is 3, 5, 6, 7. Is that negative? And that's equal to, that's negative. And so, what is negative 116 divided by negative 73? Yeah. Let's see. I'm off somewhere. Let's go back. Let's see. Anybody see the mistake? Let's see if we can catch it. So up here we multiplied by that negative 6. It gave us all that. We added. We got negative 19, 9, and negative 56. That was good. Put the original, and then we multiply by negative 3 to that first equation. Then we added negative 6. Y minus z is equal to negative 10. That looks good so far. And then we multiplied that last equation by 9. Oh, I see what happened. I was thinking of 6. I think I put a 60 over there. It should have been 9 times negative 10 is negative 90. Yeah, right there. We multiplied by 9, so that's that. So that number changed, right? So this is negative 100 and, what is that, 46? Now you divide that by negative 73. Does that give you 2? 146 divided by 73 is 2. So that was the mistake there. So good. So once we have that, we have the value for y. So what I'm going to do is take y and plug y back into this equation here. So that's negative 6y minus z equal to negative 10. Negative 6y minus z is equal to negative 10. So I have negative 6 times 2 minus z is equal to negative 10. So I get negative 12 minus z is equal to negative 10. Negative z is equal to 2. Z is equal to negative 2. So if I know that z is equal to negative 2, y is equal to 2, go back to the original equation. For the first one, x plus 3y minus z is equal to 11. So I get x plus 3 times y is 2 minus a negative 2, that's equal to 11. So I get x plus 6 plus 4 is equal to 11. X plus 10 is equal to 11. Let's see, I get x is equal to 1. Is that, here I got x equal to 3. Let's see. Let's check our answer. So let's check to see if x is 1, y is 2, and then z is negative 2. So I go to this equation up here. I get 6 times 1 minus 2 plus 3 times negative 2. What does that give us? That gives us 6 minus 2. That's 4. Minus 6. That means my x is wrong. Oh. Anybody see the mistake? Should be a positive 2, right? This is 8, and then we subtract 11 minus 8. And that gives us 3. So 3, 2, negative 2. So, I mean, here's the cool thing is once you get your answer, check those numbers into each equation to make sure they check out, just to make sure that you're right. Because if you're wrong, you can go back and, like I did, check my steps. So, you know, the method is subject to human error, right? So that's always a possibility. So check your answer. So plug in 6 here, the value for x, 3 minus 2 plus 3 times negative 2. So we get 18 minus 2 minus 6. That's minus 8. That's equal to 10. That checks. Then the next equation, we get 3 plus 3 times 2 minus a negative 2. This is 3 plus 6. That's 9. Plus 2, that's 11. That checks. And then 3 times 3 for that third equation. I'm just going back to the original system, plugging in my values, plus 3 times 2 minus 4 times negative 2. This is 9 plus 6 plus 4 plus 8. Right? So here that gives us 23. That checks. So now on the test, since these obviously these 3x3s take a minute, so I just have one of those like that, right? So, but what you want to do is once you get your answer, go back like I did and check just to make sure that, and don't just check one equation, because I've seen this in the past. I can take like what I think is my answer, plug it into one equation, it works, and I get the answer. Then you plug it into the second or third equation, it doesn't work. That answer must satisfy all 3 equations because it's called the unique solution. Okay, so and this is probably good that you saw today, even, you know, for me working and kind of see how tricky that stuff is, right? So you just got to take your time and just always go back and check your math. Thank you. Y'all have a good weekend.